Hi everybody, this is going to be our note for 5.2, partial variation. We looked at direct variation in 5.1, so we're learning about this variation in 5.2. So another quick investigation. It says the Keg restaurant charges $100 to reserve a private dining room plus $40 per person. So it says write an equation to show the relationship between the cost of the reservation and the number of people attending. So let's try and use x and y here, just because it'll make it easier when we look at a graph. So let's write our let statements. Let x represent something, and let y represent something. So what's kind of changing in this question? Well, what thing depends on the other? We can think of that too for independent variables. So it looks like, money's involved. So we talked about for independent variables, anything involving money is usually a dependent variable. So let y represent the total cost, let's say. And I guess they're telling us right here as well the cost of the reservation and the number of people attending. So the cost does depend on the number of people attending. So we'll say let x represent the number of people attending. So we can say the cost is equal to, well, no matter what, we have this $100 to reserve a spot, so we'll just kind of put that there as our kind of a down payment, just to, again, just get that private dining room. And then on top of that, it's $40 per person, or $40 times the number of people attending. So what is different with this equation compared to our direct variation equation, which was just y equals mx? Well, we can see that this is kind of our direct variation, but there's something added to the end of it. So that's kind of the difference. Similar to y equals mx, because we still have a constant of variation, but we have a number added to the end. So that's kind of the difference. Like, this looks the same as direct variation equation, we just have something added to the end of that. So now we have our equation. It says how much will it cost to reserve the room if an extended family of 25 want to have a dinner to celebrate a birthday. So we know that the number of people here is x, so x is equal to 25. I'm going to get my equation and just make the x equal to 25. I guess I should be proper and write my original equation as well. X becomes 25. Then we can say 40 times 25, which I should be able to do in my head, but I don't think I can. So I'm just going to use a calculator. I get 1,000. I should have been able to do that in my head. Oh well, it's okay. So $1,100. So therefore, it would cost $1,100. Now it says the Philadelphia Eagles want to celebrate their 2018 Super Bowl victory. A little bit dated, this note. There are 24 players and 6 coaches attending the celebration. So how many people are going in total? Well, 24 players and 6 coaches is 30 people. So x is equal to 30. So again, we just use our equation. Y is equal to 40, x plus 100. 40 times 30 plus 100. 1,200 plus 100, so it's going to be $1,300. So again, we have to have our sentence, therefore, it would cost $1,300. So we're just going to do a quick recall now of, like, what did we learn from 5.1? We learned about direct variation. It's a relationship between two variables in which one variable is a constant multiple of the other, meaning they're going up by the same amount. Meaning if I double the amount of time, I would double the distance. So they go by a constant multiple of each other. The constant of variation is that constant multiple. So it goes up by the same m multiple. So that's our constant of variation. We can also call that our rate of change, meaning how much something's going up by. So like the speed was like going up by 150 meters per minute. So like that's our rate of change. It's represented by this equation, which is also represented by these equations here, which look very complicated, but I assure you are not that bad, and we're actually going to be looking at that in 5.3. So there are other ways we can calculate this constant of variation, also known as this rate of change. So direct variations pass through the origin, we said, and have this equation y equals mx. So now what we're going to do is compare direct variation to partial variations in this other little example here. So we have the Tesla Electrical Company charging $25 an hour to do electrical work, plus a fee of $50 for the estimate of the proposed work. The AC/DC Electrical Company just charges $50 per hour. So we're going to write equations to model each relationship, and we're given now some variables. So we're going to let C represent the total cost of any work done, and let H represent the number of hours worked. So for Tesla, it says they get $25 an hour. So I guess we can say cost is equal to $25 per hour each. And there's a fee of $50 for the estimate. The AC/DC Electrical Company, well, they just charge $50 per hour of work. So this looks like direct variation, just because we don't have anything added here, but this looks like partial variation because it kind of looks like the equation we looked at on the very first page. So now we can use equations to create tables of values to organize the data for 0 to 4 hours of work. So the way we do this is we can put our H for hours. Well, they give us the values for H. We're going to use 0 to 4, 0, 1, 2, 3, 4. And like we did with the table of values before, I'm just going to kind of put my equation here, 25 H plus 50. And we're just going to be putting in these new H values to get our corresponding cost for that. So what happens at 0? What is the cost? Well, 25 times 0 plus 50 is just 50. So we actually end up getting a coordinate of 0, 50 here. Because, again, this is our coordinate. Our independent variable is H, which means it's going to be on our X value. So when we graph it, it's going to be on the X axis. The cost is the dependent variable, because cost depends on time. So that'll be the Y value on our Y axis when we're graphing this. So we're going to do this for the Tesla Electrical Company, and we'll do the same thing for the AC/DC Electrical Company, where we have just 50 H is equal to C. So that's like what we did in 5.1 lesson. Or 50, times 0 is equal to 0. So we'll have like another point here. So we have like 0, 0 here. So I'm not going to waste time by doing this in the video. I'll just fill it in, and then you'll see it in a second. So if you want, you can pause the video yourself, try it out, and then compare my answers in just a second. Alright, so this is what we can kind of see when we film the graph. You can check your answers with mine. So these are the coordinates we're going to be plotting, and this is our work to show how we got those. So all we did was we inputted our independent variable into the equation, and then solved for the dependent variable. And then we just took the independent variable, which is our X value here, and then put in the dependent variable, which is our C value here for Y. We just did this for all of these to get these points. So which relation is direct variation? How do we know? Well, we can see that AC/DC is a direct variation. And how do we know that? Well, we have to look at where does it start, or what does it pass through? It passes through the origin. The graph oops, passes through the origin. So this is direct variation, goes to that origin. This one does not. So we can kind of guess what we're going to call that one though. So on the next page, we're just going to graph this information. Again, if you want to pause the video and try graphing it yourself, try making the proper scales, making sure you label the axes correctly, and then compare it to my graph, which will be just on the next page in just a minute, or a few seconds. I'm going to pause the video and just fill it in. So I filled in just my axes and I've labeled these. I'm actually going to put the points in now because I wanted just to go over that of our scaling here, because our numbers, I wanted to make sure that we are going up by the same scale. So like I was going up by, it seems like 25 here, and these ones are going in intervals of 50, so my scale just went up by every other line was 25, just so I could spread out that information. So for the, let's do the direct variation first, because it's a little bit easier. We know we're going to start at the origin. Then we have at 150, 2, 100, 3, 150, 4, 200. So that's just me plotting my direct variation points. And then I should label this line as well. We're going to label this one for AC DC here. And then our next set of points was for the Tesla Electrical Company. We had 0 and 50. Oops. 0 and 50. We then had 1 and 75. 2 at 100. 3 at 125. 4 at 150, which is here. So we see that this one's a little less steep, but then becomes a little steeper later on. So this is our Tesla one. So looking at either graph or the table, we should use which company for 3 hours of electrical work. Does this company always have the best deal? So looking at 3 hours, which company gives us the better deal? And in this case, because we're measuring cost, it's going to be the lower line, like Tesla here, according to my graph, but also according to my table of values. If we just look at our table of values, at 3 hours, it costs 125, and at 3 hours with AC/DC, it costs 150. And now we can see that on the graph because the Tesla company is at 125 here, and AC/DC at 150. This is a higher number here. So at 3 hours, we should be using the Tesla company because they cost less. Tesla Electrical Company. For 3 hours electrical work, do they always have the best offer? Yes or no? Well, not really. Like, it seems like beyond 3 hours, it seems to be lower than AC/DC. At 2 hours, they actually cross. So I think this is, well, not I think, I know, this is when they cost the same amount. So no matter what, at 2 hours, it always costs $100 for Tesla, and it costs $100 for AC/DC. So that's when they cost the same. But if it's less than 2 hours, we see that Tesla is actually a bit more expensive than AC/DC. AC/DC is actually a bit lower because they have this, well, Tesla has that $50 to do that estimate, so that's why it starts a little bit higher before 2 hours. So does this company always offer the best deal? No. It depends on the number. Oops. Number of hours worked. If it's less than 2 hours, we saw that less than 2 hours, AC/DC costs less, and then for more than 2 hours, Tesla, sorry, this is capital T. I did a lowercase, I tried to fix it. Tesla costs less. You also know that at 2 hours, if you know it's going to be 2 hours of work, it doesn't matter who you call, maybe just whatever is more convenient. But less than 2 hours, AC/DC is cheaper, and then more than 2 hours, Tesla seems cheaper, or is cheaper. And what is different about these two relations? Well, what is different? Well, which one is steeper? We can say that AC/DC is a steeper line, and we can say that it costs more over time for longer period of time. For a longer period of time. And Tesla is less steep, but costs or has this kind of, we call this kind of like an initial cost, like we have to pay this $50 no matter what, as an initial cost, which makes it kind of more expensive at the beginning. So partial variation is a type of relationship between two variables in which one variable is a constant multiple of the other. And if we just stopped there, that would just be our definition of direct variation. So they're both the same in that they both have two variables, and one variable is a constant multiple of the other. But partial variation has some other constant value added to it, so plus some constant value. So partial variations are relations that never pass through the origin. So direct variation passes through the origin, but partial variation never does that. And we model this equation through this equation, y equals mx plus b, which I think I mentioned before in chapter 4 and saying that we're going to be looking at this a lot. So m represents our constant of variation, also known as our rate of change, and b is the fixed value or the initial value, also known as the y-intercept, because that's where it crosses the y-axis. So we call that a y-intercept. So for our next example, let's complete the following chart given that y varies partially with x, and we may need to determine the constant of variation, but we're going to just look at the next page right now. So the notes kind of got a little bit cut off, so that's why the example 1 isn't up here. But here's our table of values. We can kind of see just between these two that we're going up by 3s. It's going to be 12, 15, and then 18. So then, well, it jumps to 27, so this isn't going to be 5. We have to see what number is going to go here for it to be 27. So 21 would be 5, 24 would be 6, and then I guess 7 would be 27. So it says, what is the initial value of y, or fixed cost? So initial value happens when x equals 0. So when x equals 0, y is equal to 6. So our fixed cost, also known as the initial value, also known as the y-intercept, is y equals 6. Or we can also put it as a coordinate if we wanted to, 0, 6 if you wanted. So now we have to find our constant of variation m, and remember that constant of variation is how much is each of these going by when these goes up by a certain amount as well. So we can see with the y values. Before, with our direct variation, we saw if they're going up by the same number, that ended up being our constant of variation. Like if the person was running 150 meters per minute, well, that meant that constant of variation ended up being their speed, which was 150 meters times the number of minutes that went by. So we can see that with our y values here, they're going up by 3. So we can say our constant of variation is going to be equal to 3. Now we also saw another way to calculate this. Well, when we did our kind of review of direct variation, we saw this thing called this equation, kind of triangle y over triangle x. Now the triangle might be a new kind of symbol they're used to seeing. So triangle actually means the difference. So another way we can calculate this constant of variation is getting the changes or the differences in the y values and dividing that by the differences or the changes in the x values. So notice that the y values here are going up by 3 every time. So the difference between these is 3. And then my x values are going up by 1 every time. So that's like saying 3 over 1, which is equal to 3. So our constant of variation is also equal to this equation. So there's a few ways that we can calculate constant of variation, but this is just another way. So that's how we also get m is equal to 3. So now that we have the fixed cost, we said was 6, and we have the constant of variation, well, we can write an equation for that. Y is equal to mx plus b. We said m is equal to 3, and our fixed cost is actually that letter b there. So the fixed cost is 6, so y is equal to 3x plus 6. And now it says to graph the relation, so I'm going to use some different x values here, so you can try graphing it yourself as well, and then pause the video, and then when you unpause it, I'll have this up in just a few seconds. So here's my graph here. We don't have any units or titles specifically, so I just put kind of this is x and that this is y. My x-axis went up by every other line is 1, and my y-axis went up by every line is 3. So then I put my points, from my table of values like 0, 6, and 1, 9. I put 0, 6, 1, 9, 2, 12, and so on. And then we just kind of join these dots with a line. Like that. So this is what our graph looks like. So again, it looks like a straight line, so it's kind of that, kind of looks like direct variation a little bit because it's a straight line. But again, partial and direct variation, they're always going to look like a straight line, meaning they're always a constant multiple each of the points. But partial variation starts at something besides the origin, and direct variation always passes through the origin. It might start at the origin, it might start below, but eventually it'll go through the origin. But partial variation just does not start at the origin. So our last example is that MPG is planning an awards banquet. The cost of renting the banquet facility and hiring staff for the event is $675, and then an additional cost of $12 per person per meal. So what is the fixed cost? So what do we have to pay no matter what? It's always going to cost $675 no matter what, just to get the space and to get the serving staff. And then what is the variable cost? What varies in terms of the cost? Well, that's the $12 per person per meal. So M is going to be 12 because it depends on the number of people attending. So write an equation to represent the relationship. Well, y is equal to 12x, 12 times the number of people, plus the $675, which you have to pay no matter what. So then what if we had 500 people attending the banquet? Well, now that we have this equation, we can kind of estimate how much it would be. So then I'm just going to multiply 12 times 500. 12 times 500 is 6,000 plus 675, so we get $6,675. So therefore we can say it costs $6,675. So just a quick way just to, again, further understanding of partial variation. So at the very bottom, I've given you just kind of a summary of partial and direct variation. So from direct variation, it has a table. In a table, it has 0, 0 as an initial value. So like if I have x and y here, you'd have like 0, 0, 1, 2, 2, 4 kind of thing, as long as it's going up by the same amount. 3, 6. Keep in mind, as another example, could be like -1, -1, 0, 0, 1, 1, 2, 2. So it just has to pass through the origin. It doesn't have to necessarily start there. But a lot of our graphs, if we don't have negative numbers, it's going to start at 0, 0. If it's direct variation, it passes through the origin. That's our origin there. And our equation is always just y equals to that constant of variation times x. So mx here, but m could be 2 or 4 or 6 or whatever. For partial variation, it starts at something besides 0, 0. So it could be like 0, 2, then 1, 4, 2, 6, 3, 4, 6, 8. So it's starting at something besides the origin. And on a graph, it goes anywhere besides the origin. So notice it's passing through up here, not through the origin. Then our equation is in the form of y equals mx plus b. So as an example, like y is equal to 4x plus 10. This is partial variation because we have this thing added to the end here, while direct variation doesn't have anything added to the end. So the whole point of these two sections is just, do we understand the difference between direct and partial variation, and how are we with our graphing, basically. So please try some of the homework, and thanks again for your time.